In this video, we will discuss applications involving quadratic equations and quadratic functions. And basically, these applications are going to be an additional applications to our projectile motion problems. Those are also applications that involve quadratic equations and quadratic functions. We're going to look at a couple of examples. Again, these are word problems, and of course, we've already gone through the process of problem solving to help us figure out word problems. And so I'm not going to go back over those steps, but I will use them as we go through these examples here. Our first example involves a consecutive integer problem. Remember that when we looked at linear equations, applications of linear equations, we also looked at consecutive integer problems. But this one's going to be a little bit different. Let's read the problem and see why. It says two consecutive positive odd integers have a product of 255. I want to find the integers. Remember that when we said consecutive, we means they fall right next to each other, one right after the other. And they're positive and also odd. Odd numbers are numbers like 1, 3, 5, 7, 9, 11, so on and so forth. And so if we want to solve this problem here, we got to come up with some variables because we don't know. We have a lot of unknowns here. We want to find the integers. We don't even know the first integer. So what I'm going to do is I'm going to come up with the variable for my first odd integer. I'm going to abbreviate integer with int. And then I'm going to come up with an expression for my second consecutive odd integer. Okay? Since I don't even know the first, I'm going to let that be given by x. And if I want to write an expression for my second consecutive odd integer, right, remember, consecutive integers are integers like 1, 3, 5, 7, right, consecutive odd. To go from one to the next, we have to add 2 each time. And so if x is my first odd integer, then the next one that's consecutive after the x is going to be an x plus 2. All right, and so I have an expression for my two positive odd consecutive odd integers, and then it says that they have a product of 255. Remember, product means multiplication. So if I take x and if I multiply it by x plus 2, I should have a product, meaning they should equal 255. Now I have all the information I need to find my two variables, my two integers, by solving for my variable x. Of course, we got to use the distributive property because since this is going to be a quadratic equation, we're going to want everything on one side. So I've got to distribute. I get x times x is x squared, x times 2 is 2x, and that equals 255. Of course, quadratic equation, we see our x squared here. Highest power of x is 2. So I need everything on one side set equal to 0. Therefore, I'm going to subtract 255 from both sides. All right. On this left-hand side, nothing combines. I don't have any like terms. So I'm going to leave this as x squared plus 2x minus 255. And on my right-hand side, 255 minus 255, they cancel, or you can think of that as just 0. All right, now I'm ready to factor. There's a 1 in front of my x squared. Of course, there's no GCF in this example. So I'm going to put an x here and an x here. And so I want to find two numbers that multiply to give me negative 255, but add up to a 2x. Of course, we already know how to do this, so I won't take the time, but a positive 17 and a negative 15, so I'm going to write it as a minus 15, they will multiply to give you negative 255 and add up to a positive 2. All right? And so now I have two things that multiply together to give me 0, so I'm going to set them both equal to 0 so I can solve for x. So I can get all of my solutions, and I put an extra equal signs here. I meant to say or x minus 15 equals 0. Notice here, if I subtract 17 from both sides, the 17 is going to cancel over here, and I'm just going to be left with an x. And when I subtract 17 from 0, I'm going to be left with a negative 17. So I get x equals negative 17 as a possible solution. And on my other equation, I have to add 15 to both sides. Notice that when I add 15 to this side, it's going to cancel with this negative 15, so I'm going to be left with x. And when I add add 15 to this side, I'll get 0 plus 15, which is a positive 15. And so right now, it looks like my solutions involve negative 17 and 15. However, remember what you're looking for. I'm looking for two consecutive positive odd integers, right? Negative 17 is not odd. It's not a negative value, a positive. It is a negative value, so it can't be part of my solution. Therefore, 15 is the x value that I'm looking for. Now, of course, I want to find the two integers, right? And so since x represents my first odd integer, and I know that x equals 15, I know that 15 is an actual part of my solution. And to find the second consecutive positive odd integer, I use this expression here. It's x plus 2. So if I take the 15 and add 2 to it, I get 17. So my solutions would be 15 and 17. Those are my two consecutive positive odd integers. Let's look at another example. In this example, it says one positive number is 7 less than 4 times another, and their product is 65. Find the two numbers, all right? And so this is an unknown number problem, right? Not necessarily consecutive. They could be, but this is unknown, all right? And so what I'm going to do, since I read the problem, I'm trying to find two numbers, and they give me some information so that I can at least write an algebraic expression for both of the numbers, right? And so I'm going to let x be a number, all right? Some number. All right. I'm going to call it x, and then I'm going to have another number. All right. And so I'm calling the first one x, and then I'm just going to write the other one based off of this part of my sentence here. It says one positive number, notice that it is positive, is 7 less than 4 times another, right? And so if I'm calling one x and I want to write the other in terms of that, then I've got to figure out how to write 7 less than 4 times, all right? Well, by my order of operations, I need to do the 4 times first, so I get 4x, and if I want 7 less than that, I have to take away 7 from it. And so I get 4x minus 7. So now I have an algebraic expression for both of these numbers here. One is given by x, the other is given by 4x minus 7. Now I can come up with my equation by using my knowledge of what product means. Product means to multiply those two things together. And then I have a product of 65, right? And so to set up this equation, I'm going to have an x times 4x minus 7 equals 65. And this is the equation that I want to solve, right? In order for me to solve that, I'm eventually going to have to get 0 on one side. Before I do that, I need to use my distributive property. I get 4x squared minus 7x equals 65. Of course, this is a quadratic equation. I need everything on one side set equal to 0 so that I can solve by factoring. That means I need to subtract 65 from both sides. Once I subtract 65 from both sides, nothing on the left-hand side combines, but they cancel over there. And now I look at this equation here, and I want to factor. First, always think about your GCF. If I look here, I have a 4, a negative 7, and a negative 65 as my coefficients. Notice they don't have any common factors, so that's a sign that I'm not going to have a GCF, which is true. Notice that there is a number in front of my x squared. Remember, you can use trial and error, or you can use that rainbow method that we've been discussing, right? I'm going to go through the rainbow method. Remember, we multiply the 4 by the negative 65. If you multiply 4 and negative 65, you are going to get a negative 260. And so what we need to do is find two numbers that multiply to give us negative 260, but add up to a negative 7. And so if you go through your factors of negative 260, a positive 13 and a negative 20 will work for you, all right? And so my goal is to write this negative 7x as a 13x minus a 20x. And so we're going to do this, and I'm going to come off to the side for a couple of seconds to do that. And so my quadratic equation that I'm going to solve is 4x squared plus 13x minus 20x minus 65 equals 0. All right? And notice here, I just rewrote this negative 7x as this 13x minus 20x. And the only reason why I did that is so that I can eventually factor by grouping. Let's factor by grouping now, right? I'm going to group these first two terms together, the second two terms. Out of the first terms, I can factor out an x. I'll be left with a 4x plus 13. Out of my second two terms, I can factor out a negative 5. And when I factor out that negative 5, I'm going to be left with a 4x plus 13 as well. Notice my right-hand side stays equal to 0. I have a 4x plus 13 here and here, so I can factor that out. I have a 4x plus 13 times an x minus 5 equals 0. And now I have it factored completely. I have two things that multiply together to give me 0. And so what we need to do is set each of these equal to 0. So I'm going to take the 4x plus 13, set it equal to 0, give me one of my solutions. Or my solution can come from setting x minus 5 equal to 0. In this left equation here, I'm going to subtract 13 from both sides. When I subtract 13 from both sides, I get 4x equals negative 13. And last but not least, I can divide both sides by 4. And so I'm going to get x equals negative 13 over 4. In my other equation, the x minus 5 equals 0, I can add 5 to both sides. When I add 5 to both sides, I'm going to get x equals 5. Now, I've got to make sure that these are my solutions, right? I'm thinking that x equals negative 13 over 4 and x equals 5 is my solution. Let's reread the problem so that we can make sure we get our correct solutions here. All right, it says one positive number. So that's a sign that, hey, this negative 13 over 4 here is not going to be my solution because it is negative, right? So one positive number is 7 less than 4 times another, and their product is 65, right? That means since this has to be a positive number and the product is going to be 65, right? The only way I'm going to get a positive 65 and one of my numbers is positive is for my other integer that I have to find to be positive. So there's no way that this negative 13 over 4 can be my solution, all right? Therefore, the only solution I get from when I solve my equation is x equals 5, right? Now, in order for me to find my other solution, remember that we came up at the beginning of this problem with these variable expressions here, right? Of course, we have our x equals 5. In order for us to find our other number, we're going to use this expression here. I'm going to plug in the 5 for x. I get 4 times 5 minus 7. 4 times 5 is 20, minus 7 is 13, and so my other number is 13. So my solution, if you want to write it down here in one little area, it would be 5 and 13. Let's look at one additional example. This example involves a geometry problem, all right? We've talked about geometry problems before dealing with a rectangle, which this one also deals with. Remember, a rectangle is a four-sided figure with 4 right angles, opposite sides are parallel. And we talked about the perimeter of a rectangle before, but in this example, I want to talk about the area of a rectangle. Remember, the dimensions are length and width, so I can call this side length and this side here width, which is from here to here and here to here, and then this side here, my length, if I were to measure it, both of those sides would be the same length, right? And so if I want to find the perimeter, remember we said that we just add up the distance around, right? 2L plus 2W is a short way to write that. Well, if I want to find the area, I want to know how much space is taken up here. And so in order for me to do that, I've got to take my width, which is this distance here, and I've got to fill it in all the way until I get to the end of my length. And of course, I'm coloring this in, so it's not going to be perfect here. But one way to represent that mathematically is to do it by multiplication. All right, and so the formula for the area of a rectangle is area equals the length. I'm going to let that be given by L times the width, right? So I'm taking this width and applying it and measuring it the entire distance of my length, right? And that's why we have this multiplication here. So area equals length times width, right? Now what we're going to do, we're going to apply this to quadratic equations, quadratic functions, quadratic equations. Of course, when we have a quadratic equation, we only have one variable. So in all of these problems that deal with the area of a rectangle here, I'm going to have to eliminate at least one of these variables here, all right? Let's look at this example so that we can see how to do that. It says the area of a rectangle is 150 square inches. If the length of the rectangle is 5 inches less than twice its width, find the dimensions, remember dimensions mean length and width, of the rectangle. All right, we already know what formula we're going to use. We're going to use A equals L times W. But again, I can't use all three of these variables. So what I'm going to do is I'm going to come over to the side, and I've got to reread this problem so that I can come up with an algebraic expression for each of these variables here. Some of them are going to be constants. Some of them are going to be algebraic expressions that involve variables. So I'm going to reread. It says the area of the rectangle is 150 square inches. Notice here, 150 is a number. Excuse me. So I have my area. Now I'm going to go to my next sentence, and hopefully it'll tell me something about my length and my width. It says the length of the rectangle. So this is a sign that they're going to tell us what the length is. It is 5 inches less than twice its width. And so one way for me to write that, I'm going to let W be my width. And if my length is 5 inches less than twice the width, I can write it as 2W minus 5. So now I have an expression for my length. My width is just going to stay W as my variable, and my area is going to be replaced with 150. So I'm going to come to my formula here. 150, 2W minus 5 times W. Of course, we can distribute here. This is going to be a quadratic equation, so I'm going to go ahead and use my distributive property. That'll be a 2W squared minus 5W. I can subtract 150 from both sides so that I can get 0 on that left-hand side. Those cancel to 0. And I get 2W squared minus 5W minus 150. Now I see my quadratic equation with 0 on one side. And so now I got to solve this by factoring. All right? Notice there is no GCF here. So what I'm going to do is I'm going to multiply. There's not a 1 in front of my x squared. I'm going to multiply the 2 and the 150, and I get negative 300. And so I want to find two numbers that multiply to give me negative 300, but add up to this negative 5 right here. And if you go through the factors of negative 300, you'll see that negative 20 and positive 15 work, right? And so I'm going to write this negative 5W as a negative 20W plus a 15W. And so my equation is going to look like this. Now what I'm going to do, since I have 4 terms, is I'm going to factor by grouping. Out of the first 2 terms, I can factor out a 2W. I'm going to be left with a W minus 10. And out of my second grouping, I can factor out a 15 as my GCF, and I'm going to be left with a W minus 10. Both of these terms have a W minus 10 as a factor, so I'm going to factor out the W minus 10. And if I factor that out, I would be left with 2W plus 15. I can continue to solve this equation for W by using my zero factor property. Two things that multiply together to give you 0, at least one of them has to be 0. So we go through and find all of our possible solutions by setting each of them equal to 0. If I add 10 to both sides to this first equation, I get W equals 10. If I subtract 15 from both sides here to my second equation, I'm going to get 2W equals negative 15. And of course, I can divide both sides by 2. And I'm going to get W equals negative 15 over 2. All right. So I have 2 options for my width. Right? But one of these options doesn't make sense. All right? And the one that doesn't make sense is the one with the negative sign. When we're talking about application problems, we're not going to have a negative length or width. And so I can go ahead and eliminate this answer choice, or this answer that I got, because it does not make sense in the context of this problem. So I know that the width of my rectangle is going to be 10 inches. My goal is to find the dimensions, meaning the length and the width, right? So I found the width. Now I need to go and find the length. Well, I'm going to go back up to where I defined what my length was. My length is given by 2W minus 5. We just found that W was 10, right? And so if I want to know the length of this, I'm going to put 10 in for W. I get 2 times 10 minus 5. That's 20 minus 5. And of course, 20 minus 5 is 15. So my length is 15 inches. All right? And so if you want to write them together, it's going to be 10 inches by 15 inches. All right, this is my width, this is my length. All right, and that concludes our video on applications of quadratic equations and quadratic functions.